I'm Anil Kumar sharing with you a real life situation which we will model with linear equation. The question here is, during the morning walk of an hour, Anil walks at an average speed of 4 kilometers per hour and jogs at the rate of 6 kilometers per hour. We have three related questions for this situation. A. Graph the relation. B. Use graph to find the distance he travels if he spends twice as much time jogging as walking. And part C is there a combination where the distance of walking and jogging is same? You can always pause the video, answer the question, and then look into my suggestions. Now, for any word problem, one should definitely read it twice. And while reading second time, you should try to understand what is given and what you need to figure out. So let's read it once again. It says, during the morning walk of an hour, so total time is an hour. Anil walks at an average speed of 4 kilometers per hour. So this is the walking speed. And jogs at a rate of 6 kilometers per hour. So that is the given information. So the information given to us is total time of walking and jogging. Do you understand? Equals to 1 hour. This is given to us. We are also given that the speed of walking is 4 kilometers per hour and speed of jogging is 6 kilometers per hour. This is given to us. Now, does that help you to graph the relation? What kind of relation are we looking into? And to graph, we need two variables, one independent, one dependent. Now, in this case, what could be independent and what could be dependent? So these are the questions which should come to your mind when you look into a question like this. Well, here we are talking about walking and jogging. Both are like any one of them could be independent. So let's choose walking to be independent and jogging to be dependent, right? Okay, so we'll take walking as W. Now this W is actually time, so it is walking time, right? Since we have a total time of walking and jogging 1 hour, that should give you an equation. So we'll say walking time in hours. And here we'll say jogging time in hours. Does make sense. So this is actually time. So time of walking, you can also write capital T and W subscript just to signify that it is time. Is it okay? So let's use that convention. We can say T capital and W. That is time for walking and this is time for jogging. Does it make sense to you? Okay. So we have these two times here. So we'll say let jog time be TJ, right? TJ, and walk time be TW, right? Does it make sense? T for time, W for walking. So at times we use these kinds of subscripts to help us understand what the variable means. Okay. Now, is there a relation between these two? We say total time of walking and jogging is an hour. That means sum of these two should be 1, right? So that gives us the relation. So that gives you a relation that, now let me write big and bold, the relation between these two, and that is, I'll use this space here, TJ, okay, plus TW equals to 1. Okay, so this is T, not J. TJ plus TW is 1. That becomes the relation. Correct? So the graph which we are talking about is about jog versus walk times. Is it okay? and their sum is 1. 1 is hours. By selecting a unit as 10 minutes, we could actually simplify our calculations. So now the important question is how to select units or scale. So we say, well, let 10 minutes be 1 unit. So that is our scale. So this is 10, 20, 30, 40. Okay, we are almost at the end now. 50 and 60. Okay, so that gives you an hour. So we'll write this as 1 hour. 1 hour, correct? Now on the other side, I think same 1, 10, 20, 30, 40, 50, 60. So right at the tip of this, we have 1. And this is an hour, right? Joining these 2 points actually give us the graph. So we'll just join these 2 points. So I hope you are there with me up to now. There's no problems, correct? So that is the graph. And the equation of this graph is time for jogging, right? This time I'm correct, plus time for walking equals to 1. Do you get an idea? Everything is in hours, correct? So that is how you should graph the relation. So I hope all the concepts are clear to you. Selection of independent and dependent variable, it could have been the other way, same result. Second, selection of your variables. T, J, T, W makes sense. Time to jog, time to walk. And then total time is 1 hour, so just add them up to an hour. Selection of a scale, 10 minutes, because we know 1 hour equals to 60 minutes, right? So that makes sense. 10 minutes, 10, 20, 30, 40, 50, 60 minutes is an hour. With that, let's move on to answering part B and C, and I will do that in another paper, right? So I have a paper here connected. We'll continue and answer the other 2 parts here. Let me summarize before we begin. It is almost the same page, similar structure as we did earlier. So what we did earlier was we selected a scale of 10 minutes, resulted into an hour with this tip, right? This becomes an hour, and we have sketched a graph which was for jogging oblique walking time. By joining the line, joining the points, an hour on the x-axis and an hour on the y-axis. So these are also called x and y intercepts. What does that mean? If I am talking about this intercept, which is basically jogging time in hours, we'll call this as a j-intercept. And this was walking times in hours, we'll call it a w-intercept, a walking intercept, right? Now intercept here really means that Anil, the question was, during the morning walk of an hour, Anil walks at an average speed of 4 kilometers per hour and jogs at a rate of 6 kilometers per hour. So if he just walks at the rate of 4 kilometers per hour, he is going to cover a distance of 4 kilometers. And if he just jogs at the rate of 6 kilometers per hour, he is going to cover a distance of 6 kilometers. So that is all these intercepts represents. So I hope you understand and appreciate the importance of these intercepts. That means only jogging or only walking. The equation of this curve which we found out was time for jogging, right? Time for jogging plus time for walking is an hour, correct? Now let's begin from here, and we need to answer part B, right? So we did part A, which was to sketch the graph. Part B, let me copy the question, is use the graph to find the distance he travels if he spends twice as much time jogging. So let me show you what part B was. Part B was Use graph to find the distance he travels if he spends twice as much time jogging as walking. So jogging time is twice walking time. So let me write down the equation. Time for jogging is equals to twice time for walking. That is what is part B, and we have to find the distance, and we have to find distance. So we have to find distance. So that is part B for us. So let's begin from here. We know the equation is sum of these two times is an hour. So we know that time for jogging plus time for walking is an hour. Now the condition is, this is a condition, right? That he jogs twice as much as he walks time-wise, right? So that means we can replace Tj with T 2 times walking time. So we have 2 times walking time. So if you add these like terms, we get 3 times walking time is 1, or we can say walking time is 1/3 of an hour. Do you see that? The units are an hour. So we get walking time as 1/3 of an hour, right? So if we are using the graph, an hour, 1/3 means what? 20 minutes, right? 10, 20 minutes. So we took a scale 10, or you could do, this is like dividing into 3 equal parts, correct? So this graph is not very clear, however, I think that makes sense. So that is 1/3. So if I go up, what do I see? I do get the jogging time also, and obviously it is 1, 2, 3, 4, 40 minutes, right? Which is 2/3, right? This is 2/3 of an hour. This is 1/3 of an hour. So what we get is that the walking time is 1/3 of an hour, and we can calculate the jogging time from here, right? So let's calculate the jogging time from here. So Tj is 2 times 1/3 of an hour. So Tj is 2/3 of an hour, right? So when we say 1/3 of an hour, we mean 20 minutes, right? We means Tw equals to 20 minutes, and Tj is 2/3 twice this 40 minutes. That makes sense. If you add that up, you do get 60 minutes total time. Is it okay? So that is kind of a test that yes, we are on the right track. All right. But what do we need to find? We need to find total distance. Okay. How will you find the distance covered? Well, here's this very important triangle which we have been using many times, which relates distance, speed, and time. So distance is speed into time. So we say distance is equal to speed times time. That's the relation which we are going to use. So we have walking distance and jogging distance. So let me write here jog distance plus walk distance. Okay, so how much is the jogging distance? We are jogging for 2/3 of an hour, right? And the speed is 6. So it is 6 times 2/3 of an hour plus what is walking distance? Walking for 1/3 of an hour, 1/3 of an hour, and with the speed of 4 kilometers per hour, with 4 kilometers per hour. Does make sense to you? If you add them up, you get total distance, and that's your answer. Do you see that? Now to add them up, I'm not going to simplify this since I have a common denominator. So I'll say, well, 3 is my common denominator, 6 times 2 is 12, 4 times 1 is 4, so we get 16 over 3 as our total distance. Let me call this distance as D, right? So the distance covered is 16 over 3 kilometers, okay. That means what? We could write this as 5 1/3 of a kilometer. Do you see that? So 5 kilometers and 1/3 kilometers, which is 5.333 kilometers. Does it make sense to you? Or in meters, 5,333. anyway. So what you figured out is total distance covered when jogging time is twice that of walking time. So that is the total distance covered when jogging time is twice the walking time. I hope you find very interesting. And now we'll move on to part C. Part C is, let's look into our previous slide. Is there a combination where the distance of walking and jogging is same, right? Where the distance of walking and jogging is same. So I have another sheet. We'll continue on that. I'm going to do part C, and part C is there a combination where distance of walking and jogging is same? So let me write down what we're looking for. We are looking for a combination where walking and jogging distance is same, right? That is what we are looking for. And let's summarize what we have done. To begin with, we had a graph here. So I'll just sketch that graph, joining the tips. Okay, sometimes good, to have such a point which you can always remember. And we knew this was like 1 hour, that's a 0. We took J, jogging time in hours in the y-axis, and jogging in hours, right? And this is walking in hours. Okay, and we know jogging speed is 6 kilometers per hour, and walking speed is 4 kilometers per hour. Correct. The relation between these two is we're talking about jog versus walk time, and the line represents time for jogging plus time for walking equals to 1. Okay, now the question is combination where walking and jogging distance is same. So how do we get to distance? Well, as I was saying, distance is related with speed and time, right? So let's rewrite distance is speed into time. And when we say distance is same, distance is speed into time. So we want to say that we have walking distance and jogging distance. So let's write jog distance equals to walk distance. Correct? This is what we want. And distance is product of time and speed. Jogging speed is how much? Jogging speed is 6 kilometers per hour, right? So we have 6 kilometers per hour times, that's the speed. And time is we don't know, is J, right? We have to figure out. So J is the time, so we write TJ. TJ is in hours, correct. Equals to walking distance. Walking distance speed is 4. I'm not writing units now. Okay, that is right. 4 kilometers per hour. And TW in hours. What I'm trying to show you here is hours and hours cancel, and we are left with kilometers. So that gives you an idea that the formula is correct, and we are getting kilometers both sides, right? So what we have here is 6TJ equals to 4TW. So we can say time to jog could be written as 4/6 time to walk, right? You could also write this as TJ equals to 2/3 TW. Now, how does this help you to get the solution? Big question. Okay. We have this graph where, strictly speaking, this J is actually TJ. This walk is time for walking. I should have written time here. Okay, time for jogging. So we have a relation which is a direct relation. It says that time for jogging is 2/3 time for walking. So you could actually graph it 2/3. So rise over run. So 1, 2, 1, 2, 3. Right. You could go 1, 2, 1, 2, 3. Okay, right. So these are the points which could be joined. Once you join them, you get a point of intersection, right? With the original line. So let's just join them. Okay. So that gives you a point of intersection. And what does this represent? This is our solution. This is the combination where walking and jogging distance is same. So graphically, let's say 10, 20, 30, 40 is slightly more than half. Okay. So if I have to get you the answer from the graph, I will say approximately 10, 20, 30, 35, let me write, minutes. Is it okay? And it's 10, 20, 25 minutes, let's say. So from the graph, we do get the solution. But now what we will do here is we will calculate algebraically, right? We'll calculate algebraically. We know that time for jogging is 2/3 times of walking, right? And we also know sum of their time is 1. So these two equations can help us find the solution, right? So let's go back to our equation, which is time for jogging plus time for walking is 1. Time for jogging is 2/3 time for walking. So time for walking is 1. Now we can add this. Common denominator is 3. So we get 2 TW plus 3 TW equals to 1. Cross multiply. So you get this is 5 TW over 3 equals to 1. Or we get TW. Okay, let me push this a bit here. So from here, we get time for walking as 3 over 5. Do you see that? Time for walking is 3 over 5 of an hour, which is in minutes. We can write this as 3 over 5 times 60 in minutes. Is it okay? Which is, let's do 3 times 60 divided by 5, 36. So we get this as 36 minutes. So by calculations, we get this time as 36 minutes. Do you see how close we were? Total is an hour, so what do you expect? This should be 24 minutes, right? Total is an hour. We could always substitute here. So if 3 over 5 is time for walking, what is jogging time? Jogging time is 2/3 of 3 over 5. Is 2/3 of 3 over 5. 3 cancels, 2 over 5 hours. Do you see that? So that is how we could get our solution. Now, it says combination where walking and jogging distance is same. So that is the combination. If you want, you can find the distance. Can you find the distance now? Yes, we can. Distance d for walking will be how much? Time we know is 3/5, right? And speed is 4. So speed into time. So 4 times 3/5. Do you see that? So that is 12 over 5. And 12 over 5 will be 2 and 22.4 kilometers. Is it okay? So you could use your calculator. Of course, 12 divided by 5 is in decimals 2.4 kilometers. So in this case, distance traveled will be 2.4 kilometers while walking and 2.4 kilometers while jogging. So we can say total distance could be 2.4 plus 2.4, which is 4.8 kilometers in an hour. Is that okay? Okay, so this is additional information I could have asked you. Part D, what was the total distance covered when their walking and jogging distances were same, right? So that could be another interesting part addition to this question. I hope you understand and you enjoyed this journey of relating real life situation and modeling it with linear equation. I'd like you to go through this video, it's rather long, to understand all the concepts and try some questions from your book. I hope that helps. Feel free to write comments and share my videos with your friends. If you like, that'd be great. Thank you and all the best.